Hi there, this is Mrs. Tellas. I'm going to be going over the notes for section 6.1, day 2 of 6.1. It's multiplying powers. So this first page is an exploration page trying to figure out what the rule is. And you can see here the expanded form where we write out 3 2's and 5 2's, and that gives us 8 2's, and the answer being 2 to the 8th power. Okay, so the rule states that if you keep the base number exactly the same, so it was a 2, it's a 2 here, so if you keep that 2 the same, that you can add the exponents, 3 plus 5. So your final answer is 2 plus 8, or 2 to the 8th power. And you could write that as extended form, or you could also just think about how you wanted to add that 3 plus 5 to get it. So we're going to go through some examples here. So since the bases are the same, we can go ahead and add the exponents. This is x to the 6 plus 4, which ends up being x to the 10. Same thing here, since the bases are the same, I can add the exponents. So a to the 8 plus negative 3 would end up as a to the 5th. Okay, it doesn't have to just be letters. It works with number bases as well, as long as they're matching. So I've got negative 4 as my base to the 6 plus 3, which is negative 4 to the 9th power. And here it does not work. See how the bases are different? So here I would actually multiply them out. So 3 to the 5th power and 2 to the negative 5. Well, he's unhappy. This comes from the last lesson we did. We would move him down to the bottom. I know the bottom is 32. Let's see, 3 to the 5th power is 243. So it would be an improper fraction, 243 over 32. Okay, so that one goes back to PEMDAS and to the last lesson we did. Here we have matching bases. So we're going to add the exponents. Negative 5 plus 9. So my answer is to the 4th. Here I have matching bases, so I'm going to add the exponents. So 3 to the 10 plus negative 2 is 3 to the negative 12. Except he's unhappy. So we move him to the bottom, or the denominator, and now he's happy, and that's my answer. And down here, nobody has a matching base, so I'm not going to manipulate the exponents at all. I will, however, multiply 3 times 2, just like normal, and then I'll just list the letters behind. So a to the 2nd, z to the 4th. I like them to be in ABC order, kind of using my math manners. All right, so I've got some highlights here showing you what I'm combining. So 3 times 6 is 18. And since x and x have the same base, I can add them. So 4 plus negative 2. So my answer here is 18x to the 2nd. Multiplying here, 3 times 2 is 6, times 4 is 24. And there's a 1 exponent there. 1 plus 4 plus 3. So 24a to the 8th is my answer. Number 3, same thing. I'm multiplying the 5 and the 2 together. That's 10. I'm multiplying the a's together. So a to the 1st and a to the negative 10 would be a to the negative 9. He's unhappy. I'm going to move him. And then those y's, y to the 7 and y to the 1st would be y to the 8th. Okay, and a is unhappy. He needs to be moved to the bottom bunk. So my final answer there is 10y to the 8 over a to the 9th. It's a complicated one. Okay, same thing here. I'm multiplying negative 3, 6, and 2. So that's 24 times 3, so negative 72. And the two x's can be multiplied. They have the same base, so that's x to the 4 plus negative 2. So x to the 2nd for the x, and then the y doesn't have anybody to combine with. So this is my answer. Both of the exponents are positive, so they can stay in the numerator. Okay, I have a couple more here. I think I have one more slide of explaining. So we've got 2 times 3, which is 6. And those bases with the ends have the exact same power. So n to the 3 plus negative 3 is 6n to the 0, which is the same as just 6, because n to the 0 equals 1. So let's see, negative 4 times 7 times 2 would be negative 56. I'm going to combine the c's because they have the same base by adding the exponents. So c to the 3 plus negative 2. D to the 2 is just listed at the back. So negative 56, c to the first, d to the 2. And that first power on the c is optional, not necessary. 7, there's a coefficient here, 12. Not really have any other numbers to multiply it with, so it's just 12. I can combine the j's, so that's j to the second, and there's no exponent, so that's j to the first. So j to the 2 plus 1, k to the negative 2. K's unhappy. I'm going to move him down to the bottom in a second. So 12j to the third over k to the second is my answer on this one. Okay, this is an abstract problem, but it's the same. It all has the same base. So when it has the same base, I add the exponents. So a plus b plus c. And that would be as far as I could go. Can't go any further. All right, Tammy says that x squared times x to the fourth is x to the eighth. Is she correct? No, she is not correct. Reason being is the rule says if they have the same base and we're multiplying, we can add the exponent. So x squared times x to the fourth should have been x to the sixth. She multiplied those exponents when she should have added them. So I hope that helps. I hope that it helps explain if you were absent or you don't understand or you're trying to help at home. We can do these last two here. We've got time to do those. So if I multiply 8 times negative 7, that is negative 56. And x to the third times x to the second is x to the fifth. And that's the final answer. Everybody's happy there. Negative 15 times negative 3 is 45. A to the 3 plus negative 4 is going to be negative 1. And he's going to have to be moved. And b to the 2 plus negative 5 is going to be b to the negative 3. Those two both need to be moved because they're both unhappy. The 45 is going to stay on top. So 45, a to the first, b to the third is the final answer there. Thank you for listening. I hope this helped. Ask any questions you have in class or you can email me. Thanks very much. Goodbye.